L into x plus m into y plus n into z is equal to d is the Cartesian equation of the plane. The second condition is if it passes through a point and is perpendicular to the given direction. Whereas the vector equation of the plane in the normal form is vector r dot n cap is equal to d. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty of mathematics, Vidhyaashram PU College, Temple of Excellence. In my previous class, we have discussed regarding the equation of the line in different forms. Now in this session, I am going to discuss regarding the second part of the chapter, that is the plane. So equation of the planes in different form. Now let us discuss regarding the plane in detail. Plane. So a plane is determined uniquely if any one of the following conditions are known. So a plane is determined uniquely if any one of the following is known. The first one is the normal to the plane and the distance from the origin is given, then a plane can be determined, and that equation of the plane is equation of the plane in the normal form. So the equation of the plane in the normal form is nothing but the normal to the plane and its distance from the origin is given, is called the equation of the plane in the normal form. The second condition is if it passes through a point and is perpendicular to the given direction, then the plane can also be determined. A plane can be determined. Similarly, suppose if it passes through three given non-collinear points, if it passes through given three non-collinear points, then the equation of the plane can be determined. So these three types of equations we are going to study in this concept. So that is, in this session, we are going to derive the equations of the line in these three forms. That is the normal form. What is the normal form? The normal to the plane and its distance from the origin is given. Then the equation of the plane is called the normal form. If it passes through a point and is perpendicular to a given direction, then also the equation of the plane can be determined. And if it passes through three non-collinear points, then also the equation of the plane can be determined. Now let us come to the first derivation. The very important is equation of the plane in the normal form. What is the condition? The normal to the plane and the distance from the origin is given. The normal and the distance from the origin is given. Then we are going to find the equation of the plane, which is in the form is called a normal form. Now let us come to the equation of a plane in the normal form. Now to derive the equation of the plane in the normal form, consider a plane whose perpendicular distance from the origin is d. Now consider a plane, this is the plane whose perpendicular distance from the origin is d. So therefore the distance ON is equal to d. Let PXY be any point on the plane. Therefore the position vector of this plane OP is given by OP is equal to vector R. Consider a plane whose perpendicular distance from the origin is d. Therefore ON is equal to d and d is not equal to 0 from figure. So if ON is normal to the given plane and n is a unit normal vector, n cap is a unit normal vector along ON, then this ON can be written as vector ON is equal to d into n cap, where n cap is the unit normal vector along ON. Therefore the position vector of this OP is given by OP is equal to vector R. Now since this line NP is perpendicular to ON, so therefore this is perpendicular to ON. So NP is perpendicular to ON. So if it is perpendicular means that dot product is equal to 0. Therefore NP dot ON is equal to 0. This is the construction part. See here, consider a plane whose perpendicular distance from the origin is d. D is not equal to 0. That is represented in the figure. And ON is the normal from the origin to the plane. Let n cap is a unit normal vector along the ON. And let PXYZ be any point in the plane whose position vector is vector OP is equal to vector R. Since the line vector NP is perpendicular to ON, so if it is perpendicular, NP is perpendicular to ON, therefore the dot product is equal to 0, perpendicular to ON. So therefore NP dot ON is equal to 0. np dot yn is equal to 0. This is the construction part. Since, I will go to the next page. Therefore, np dot yn is equal to 0. np dot yn is equal to 0. Now, suppose if R is a position vector of OP, vector ON plus NP is equal to vector OP. Now, since let R be the position vector of the point P, therefore, vector OP is equal to R. Now, from this diagram, vector ON plus NP is equal to OP. So, therefore, vector ON plus NP vector is equal to OP vector. Therefore, vector NP can be written as OP minus ON vector. Now, therefore, vector NP is equal to OP vector. OP vector is vector R minus ON. Since vector ON is also equal to, ON is equal to D into N cap, So, therefore, vector NP is equal to R minus D into N cap. Now, substitute here NP and ON. Now, from this equation, from NP dot ON is equal to 0. Substitute what is NP? NP is nothing but vector R minus D into N cap dot ON. What is ON? ON is equal to D into N cap is equal to 0. Right. Simplify this, you will get the equation of the plane in the normal form. Now, this can also be written as R minus D into N cap dot this N cap is equal to 0 since D is not equal to 0. Now, this can also be written as, multiply this is nothing but vector R minus D into N cap dot N cap is equal to 0. So, this can be written as R dot N cap minus D into N cap dot N cap is equal to 0. Since N cap dot N cap is nothing but 1. So, this is R dot N cap minus D into 1 is equal to 0. Therefore, vector R dot N cap is equal to D is the equation of the plane in the normal form. R dot N cap is equal to D is the equation of the plane in the normal form. That's it. Okay. Hope you followed this. Very important. You may expect this for the final examination for 5 marks. Now, listen to me. Listen to me here. I'll explain once again. Consider a plane whose perpendicular distance from the origin ON is equal to D and is not equal to 0. Vector ON is normal from the origin to the plane and N cap is the unit vector. N cap is the unit vector along the ON. Unit vector. N cap is the unit normal vector along the direction ON. So, therefore, ON, this ON is equal to D into N cap. The distance ON is equal to D into N cap. ON is equal to D into N cap. Let P, X, Y, Z be any point in the plane whose position vector is vector OP is equal to R. Since the line ON is perpendicular to PN, or the NP, since NP is perpendicular to ON, okay, since NP is perpendicular to ON, therefore the dot product is equal to 0. Dot product of NP and ON is equal to 0. That is, NP dot ON is equal to 0. Now, since NP dot ON is equal to 0, let R be the position vector of the point P. Therefore, OP is equal to vector R. Since from diagram, vector ON plus NP is equal to OP vector. So, our NP is equal to OP minus ON. NP is equal to OP is vector R minus ON is nothing but D into N cap. Now, from this equation, from NP dot ON is equal to 0 implies NP is vector R minus D into N cap dot ON vector is D into N cap is equal to 0. Just multiply, since D is not equal to 0, therefore, this is vector R minus D into N cap dot N cap is equal to 0. Multiply this R dot N cap minus D into N cap. Since N cap into N cap is equal to 1, this can be written as R dot N cap minus D into 1 is R dot N cap minus D is equal to 0. I transfer minus D to the right hand side. Vector R dot N cap is equal to D is the vector equation of the plane in the normal form is the vector equation of a plane, vector equation of the plane in the normal form. So the vector equation of the plane in the normal form is vector r dot n cap, vector r dot n cap is equal to d is the vector equation of the plane in the normal form. Okay. Now let us come to the second part. So the Cartesian equation of this plane. Now to find Cartesian form, to find the Cartesian form of the plane, to find the Cartesian equation of the plane. Let r is the position vector of the point P. Let r vector r be the position vector of P, P x y z. Therefore, vector OP is equal to r is equal to, what is the point? What are the points? X y z. Therefore, OP is equal to r is equal to xi plus yj plus z into k cap. Okay, let P x y z be the position vector of the point P. So therefore vector r is equal to vector OP is equal to xi plus yj plus z. Now similarly let LMN or the direction cosines, LMN or the direction cosines of n cap. So LMN or the direction cosines of n cap. Therefore vector n cap is equal to L into I plus m into vector j cap plus n into vector k cap. See here, let r is the position vector of the point P. Therefore vector OP is equal to r is equal to xi plus yj plus zk, and let LMN or the direction cosines of the n cap. Therefore n cap is equal to Li plus mj plus nk cap. Substitute this in the vector form, you will get the equation of the line in the Cartesian form. Now therefore from r dot n cap is equal to d, r dot n cap is equal to d. What is vector r? That is vector r is equal to x into I plus y into j plus z into k cap plus dot n cap is nothing but L into vector I plus m into vector j plus n into vector k is equal to d. Since the dot product is nothing but multiplying the coefficient of I, j and k. So coefficient of I is L, coefficient of I is a, x into this is x into L plus y into m plus z into n is equal to d. So therefore this can be put in the form, therefore L into x plus m into y plus n into z is equal to d is the equation of the plane, equation of plane in Cartesian form. This is the equation of the plane in the Cartesian form. So this is very important derivation. See here, let P be the position vector of the point x, y, z, that is OP is equal to vector OP is equal to xi plus yj plus zk, and let LMN or the direction cosines of n cap. So therefore n cap is equal to Li plus mj plus nk cap. From the vector equation r dot n cap is equal to d, substitute the value of r is equal to xi plus yj cap plus zk cap dot n cap is equal to L into I cap plus m into j cap plus n into k cap is equal to d. The dot product of these two vectors is L into x plus y into m plus z into n, that is nothing but L into x plus m into y plus n into z is equal to d is the Cartesian equation of the plane. Hence the Cartesian equation of the plane is L into x plus m into y plus n into z is equal to d is the Cartesian equation of the plane. Whereas the vector equation of the plane in the normal form is vector r dot n cap is equal to d. This is the vector equation of the plane in the normal form. Hope you followed. Right. Now let us take few problems based on this. That's it. Okay. Now let us come to this problem. What is the problem given? This is very important problem for 3 marks. 3 marker important problem. Find the vector equations. So vector equation of the plane which is at a distance of 6 by root 29 from the origin, and its normal vector from the origin is given. So what is given here? Given find the vector equation of the plane which is at a distance, the distance d is equal to 6 by root 29, and from the origin, its normal vector is vector n is equal to 2i minus 3j cap plus 4k cap. Now what is to require? The vector equation. Vector equation of the plane is vector r dot n cap is equal to d. This is the vector equation. So just find out the value of n cap. What is n cap? N cap is nothing but, now n cap is equal to vector n divided by its own length. Unit vector n is nothing but vector by its own length. N cap is equal to vector n by its own length. What is vector n? This is 2i minus 3j cap plus 4k cap divided by length of this vector is 2 square is 4 plus 3 square is 9 plus 4 square is 16. So this can be written as 2i minus 3j plus 4 cap divided by 16 plus 4 is 20 plus 9 is 29. So this can be written as 2 by root 29 I cap minus 3 by root 29 j cap plus 4 by root 29 k cap. This is the unit vector n cap. So listen to me here. What is given? D is equal to 6 by root 29 and the normal vector from the origin is n. Vector n is equal to 2i minus 3j plus 4k cap. And what is required to find the vector equation of the plane? Vector r dot n is equal to d. So find out the value of n cap. Vector n cap is nothing but unit vector divided by its own length, vector n divided by length of vector n, 2i minus 3j plus 4k divided by 2 square is 4 minus 3 square is 9 plus 4 square is 16, that is root 29. So therefore n cap is equal to 2 by root 29 I minus 3 by root 29 j plus 4 by root 29 k cap. Now therefore vector equation of the plane is r dot n cap is equal to d. R dot, this is vector r dot n cap is equal to 2 by root 29 I minus 3 by root 29 j plus 4 by root 29 k cap is equal to, what is d? D is equal to 6 by root 29. 6 by root 29. This is the vector equation for the given problem. Okay, now let us come to the next problem. What is the next problem? Find the direction cosines of the unit vector perpendicular to the plane r dot 6i minus 3j cap minus 2k cap plus 1 is equal to 0 passing through the origin. So unit vector perpendicular to the plane. So unit vector perpendicular to this plane and passing through the origin. Now what is given? Given vector r dot 6i minus 3j minus 2k plus 1 is equal to 0. This equation can be written as, this is vector r dot 6i minus 3j minus 2k is equal to minus 1, multiply by negative sign, then we will get vector r dot minus 6i plus 3j cap plus 2k cap is equal to 1. So therefore multiplying by negative sign, we will get r dot is equal to minus 6i plus 3j plus 2k cap is equal to 1. Now here just find out the magnitude. The length of minus 6i plus 3j plus 2k is equal to the square root of minus 6 square is 36 plus 3 square is 9 plus 2 square is 4. This can be written as 36 plus 4, 40 plus 9 is 49. So square root of 49 is 7. Let us represent this as equation number 1. Now divide equation number 1 by, divide equation 1 by 7 on both sides. Equation 1 is divided by 7 on both sides. Then this is vector r dot term by term division minus 6 by 7i plus 3 by 7j plus 2 by 7k cap is equal to 1 by 7. Now if we compare, this is of the form, this is of the form, the standard form, vector r dot n cap is equal to d. R dot n cap is equal to d. What is n cap here? The unit vector is, therefore the n cap vector, unit vector is equal to minus 6 by 7i plus 3 by 7j plus 2 by 7k cap. Okay. Followed. Listen to me here. See, the given equation r dot 6i minus 3j minus 2k cap plus 1 is equal to 0. Convert it into the standard form. So r dot 6i minus 3j minus 2k is equal to minus 1 multiplied by negative sign. R dot minus 6i minus into minus plus 3j plus 2k is equal to plus 1. Now find out the magnitude of this vector n, that is minus 6i plus 3j plus 2k is equal to square root of 49 is 7. Divide equation number 1 by 7. So that is vector r dot minus 6 by 7i plus 3 by 7j plus 2 by 7k is equal to 1 by 7. Comparing with the standard form, r dot n cap is equal to d, n cap is equal to minus 6 by 7i plus 3 by 7j plus 2 by 7k. Okay. Now, this shows that n cap is equal to minus 6 by 7i plus 3 by 7j plus 2 by 7k. This shows that the unit vector perpendicular to the plane and passing through the origin. The unit vector perpendicular to the plane and passing through the origin. So therefore, the direction cosines, what is required to find the direction cosines? Therefore, the direction cosines are minus 6 by 7, 3 by 7, 2 by 7. Minus 6 by 7, 3 by 7, 2 by 7. These are the direction cosines. So, the direction cosines are 6 by 7 minus 3 by 7, 2 by 7. These are the direction cosines for the given plane. Okay. Now, let us come to the similar type problem. Find the distance of the plane 2x minus 3y minus plus 4z minus 6 is equal to 0 from the origins. Now, the given equation can be written as, the given equation is 2x minus 3y plus 4z minus 6 is equal to 0, or this is 2x minus 3y plus 4z is equal to 6, equation number 1. Now, the direction ratios normal to this plane are, these are the direction ratios, 2, minus 3, 4 are the direction ratios. Now, find out the direction cosines. So, the direction, therefore, the direction cosines are, the direction cosines are 2 divided by square root of, this is 2 square is 4 plus 3 square is 9 plus 4 square is 16, minus 3 divided by 4 plus 9 plus 16, 4 divided by square root of 4 plus 9 plus 16. So, therefore, that is the direction cosines are 2 by square root of 16 plus 4 is 20 plus 9 is 29, minus 3 by root 29, 4 divided by root 29. So, these are the direction cosines. Okay. Hope you followed the direction cosines. Now, divide equation number 1 by 29. So, divide equation number 1 by 29, square root of 29. So, if you divide equation number 1 by 29, what we will get? 2 by root 29 into x minus 3 by root 29 into y plus 4 by root 29 into z is equal to 6 divided by root 29. Now, if you compare, this is of the form comparing with, if you compare with the standard equation of the plane, L into x plus m into y plus n into z is equal to d, we will get the distance d is equal to 6 by root 29. So, hence, the distance of the plane from the origin is 6 by root 29 is the distance of the plane from the origin. That's it. Hope you followed. Listen, just very simple problem for 2 marks or 3 marks it is. What is the given equation? 2x minus 3y plus 4z minus 6 is equal to 0. This can also be written as 2x minus 3y plus 4z is equal to 6. The direction ratios of the line are 2, minus 3, 4. Find out the direction cosines. The direction cosines are 2 by root 29, minus 3 by root 29 and 4 by root 29. Hence, divide this equation 1 by root 29. Then this will reduce us to 2 by root 29x minus 3 by root 29y plus 4 by root 29z is equal to 6 by root 29. This is of the form, the standard equation of the plane in the Cartesian form is L into x plus m into y plus n into z is equal to d. So if you compare this with the standard equation, you will get d is equal to 6 by root 29. Hence the distance of the plane from the origin is d is equal to 6 by root 29. That's it. Okay. Hope you followed. Now let us come to the next problem. What is the next problem? Find the coordinates of the foot. Find the coordinates of the foot of the perpendicular drawn from the origin to the plane. So the coordinates of the foot, coordinates of the foot of the perpendicular drawn from the origin to the plane, 2x minus 3y plus 4z minus 6 is equal to 0. This is also a very important problem. Now let us consider, let x1, y1, z1 be the coordinates of the foots of the perpendicular from the origin. Now first find out the direction cosine for this line. Now the direction ratios are, so the given equation is 2x minus 3y plus 4z is equal to 6. Here the direction ratios are 2, minus 3 and 4 are the direction ratios. Now here a is equal to 2, b is equal to minus 3 and c is equal to 4. Find out the value of root of a square plus b square plus c square. This is equal to root of 4 plus 9 plus 16. This is root 29. So therefore divide this by root 29. So if you will get 2 by root 29x minus 3 by root 29y plus 4 by root 29z is equal to 6 by root 29. This is the standard form. Comparing with the standard form, what you will get, L into x plus m into y plus n into z is equal to d. So therefore here d is equal to 6 by root 29 and the direction cosines are, therefore the direction cosines are, what are the direction cosines? 2 by root 29 comma minus 3 by root 29 comma 4 by 29 under root. So these are the directions. So first find out the direction cosines for the given line. Divide by root 29, 2 by root 29 minus 3 by root 29, 4 by root 29 is the direction cosines and the distance d is equal to 6 by root 29. Okay. Since the direction cosines and the direction ratios for the line are proportional, so therefore the direction ratios and the direction cosines for the given line are proportional. So therefore this can be written as, I can write this, I'll rub this and I'll write. So that is x1 divided by 2 by root 29 is equal to y1 divided by minus 3 by root 29 is equal to z1 divided by 4 by root 29 is equal to a constant k. Now find out the value of x1, y1 and z1 and substitute in the standard given equation. You will get the foot of the perpendicular, the coordinates of the foot of the perpendicular. So from this, x1 divided by root of 2 by root 29 is equal to k. Cross multiplied, x1 is equal to, this is 2 by root 29 times k. Similarly, y1 divided by minus 3 by root 29 is equal to k, which implies y1 is equal to minus k times 2 by root 29. And similarly, from this equation, z1 by 4 by root 29 is equal to k, which implies z1 is equal to k times 4 by root 29. So therefore x1 is equal to 2k by root 29, y1 is equal to minus 2k by root 29, z1 is equal to 4k divided by root 29. Now therefore x1 comma y1 comma z1 is equal to, what is x1? 2 by root 29, 2k by root 29 minus 2k by root 29 and this is 3k, not 2k, minus 3k by root 29 and 4k divided by root 29. Substituting these values in the equation of the line. Substituting in equation of line. So that is what you are going to get. I'll write here. I'll rub this and I'll write here. Now from 2x1 minus 3y1 plus 4z1 is equal to 6. Substitute here 2 into, what is x1? x1 is equal to 2k by root of 29 minus 3 into y1. y1 is minus 3k divided by root 21 plus 4 into z1 is equal to 4k divided by root 29 is equal to 6. Now this is 4k divided by root 29 minus into minus plus 9k divided by root 29 plus 16k divided by root 29 is equal to 6, or take LCM, root 29 is the LCM. This is 4k plus 9k plus 16k is equal to 6. This is nothing but 29k divided by root of 29 is equal to 6. Now, therefore, this can also be written as 29 can be written as root of 29 into root of 29 times k divided by root 29 is equal to 6. 29 gets cancelled. Root 29 times k is equal to 6, or therefore k is equal to 6 by root 29. Substitute this value in equation number here. Therefore, the coordinates of the foot of the perpendicular is equal to, what you will get, k is equal to 6 by root 29. 2 into 6 is 12. Root 29 gets cancelled. Square root gets cancelled. You will get 12 by 29. Again, minus 3 into 6. 6 3s are 18 divided by 29, comma 6 into 4 is 24 divided by 29. So, the foot of the perpendicular drawn from the origin to the given plane is 12 by 29, comma minus 18 by 29, comma 24 by 29 are the coordinates of the foot of the perpendicular. So, what are the coordinates? 12 by 29 minus 18 by 29 and 24 by 29 are the coordinates. That's it. Okay. Hope you followed this. Just find out the value of k. See, substitute the value of x1, y1, z1 in the given equation. Simplify, you will get the value of k. K is equal to 6 by root 29. Substitute the value of k in the equation with the coordinates x1, y1, z1. You will get k is equal to 6 by root 29. So, root 29 into root 29 is root 29 whole square. Square root gets cancelled. So, you will get 12 by 29 minus 18 by 29 and 24 by 29. These are the coordinates of the foots of the perpendicular. The coordinates of the foot of the perpendicular drawn from the plane is, this is the required answer. Hope you followed. These are very important problems. You may expect the derivation for 5 marks or a problem for 3 marks. Hope you followed this. So, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you.